Hey, and welcome back to Machines and More. In a recent video, I walked through the steps needed to mod the NR200 to more adequately take a top rad, and I hope you've had a chance to check out that video since I won't be covering the mod steps again here. So here we are, all looped up, and so in today's update, I'll go ahead and walk through the build components, talk through some build tips and component recommendations if you want to try something like this. And I'll also share some of the thermal performance benchmarks. For the top and bottom rads, I'm using the XSPC TX240, which is a super slim 240 that comes in at 20 millimeters thick. The top is the regular version, and the bottom is the crossflow version. Now, you pretty much have to go with a slim rad, at least for the top. And although there are a few rads thinner than the TX240, this is the more mainstream choice, and I highly recommend it, especially in space-constrained SFF builds. On the bottom, originally, I was trying for 25 millimeter fans with the EK-ACF X3M, which is a little bit more than 25 millimeters. But after pulling this GPU block and installing it in here, it was clear it wouldn't work well. Now, even with 25 millimeter fans and a 20 millimeter rad, there was only a few millimeters of space, and with a solid GPU block directly over it, the fans wouldn't do much good there. So I reversed course and just went with a slim knock to an NFA 12 by 15 for the top and the bottom rads. So there's 4 in total. The pump I'm using here is the Corsair XD3 DDC, and this one is a very good choice for this case in terms of form factor and suitability for a dual rad GPU CPU loop. Another choice that can be just as good is the EK FLT120 DDC. That one is a little bit more expensive, and it doesn't come with a temp probe, but it is clear all around, and it doesn't require a proprietary RGB solution. So it should be a better looking pump res featuring essentially the same pump. I had this XD3 already, so I just stuck this in the build. The CPU block I'm using is the EK Velocity AM4. This is the nickel plexi RGB version, which is a great block for the price. It's cooling a Ryzen 9 3900X underneath it, which is one of the hardest AM4 chips to cool due to the 7 nanometer process and lower bin silicon compared to the 16 core Ryzen 9s. But at 12 cores and 24 threads, it is still a beast of a chip for both productivity and gaming. The CPU is running on the Asus X570 Strix ITX board. Now, this GPU block is an older one. I have this one around. This one's a Heat Killer 4 from Watercool in Germany, cooling at 2070 here. I will be updating it with the 3070 once I'm able to get the Asus card that comes with the EK block. The tubing and fitting is all EK. This is 1216 DuraClear, and the fittings are a mix of copper compression fittings and black nickel polished 90s and 45s. In the loop, I've got 2 Corsair lighting strips connected to a Lighting Node Pro, which also connects to the XD3 pump. And finally, the coolant in the loop is premixed Corsair coolant. As for the build process, it is complicated, but more so because you have to be methodic, like most SFF custom loops. There is just a specific order that things have to go into the build. Ideally, you should lay out your cabling and the top rad first, then install the motherboard in underneath that radiator. But you can also do the motherboard side and the PSU side of the build first, connect up all your cables, and then just remove the top rib of the case to make sliding in that rad possible, and then screw it along with that radiator panel in. Now, I showed how to attach that and also the pump block to the PSU shroud in the previous video. For looks, and to make the cable layout a little bit more flexible, I just went ahead and ran extensions, and because I'm not using SSDs at the front, I could use the front end of the case for cable management. I did run a SATA data cable for future-proofing it in case I want to do that, and there still is space for that. Now, because I use that space between the PSU and the front for cable management, I did have to reverse course and change how I had the top rad oriented initially. This particular loop order is pump to CPU, to top rad, to GPU block, to bottom rad, and then back to the pump. It isn't as clean as I would have liked since both the CPU and GPU have dedicated inlet and outlet points, but it works. I did experiment initially with flipping the order on the block, and there was a small difference in CPU thermals, so I decided to run it the correct way. Now, I know some folks like to use the PSU in the build to prime the loop, but with a small form factor build, it's usually hard to access the cables after building, so I just keep an old ATX power supply around just for that purpose. Just plug everything in except the pump and do a quick test to make sure your system will post, and then you can start filling the loop. Just hook it up to the other power supply. I did leave the pump's peripheral plug in an easy to access location on the blind side of the side panel just for that purpose. Now, with how tight the RAM is up against the fans, I think you're going to be stuck with select ASUS ITX boards, since these have the best RAM clearance at the top. Your best candidates are going to be this one, the B550 ITX, and if you're going Intel, the Z490 Strix. The B450i should also be fine even with the 3900X, but the Crosshair Impact 8 has a high RAM slot, so I can't recommend that one. The good news is that the Strix X570i and the B450i are the best ITX boards within their respective chipsets, and although the B50i has slightly weaker VRMs than its B550 competition, it's a very decent board too. More importantly, if you're doing a custom loop in ITX, I would recommend the Strix boards anyway, since all those boards I just mentioned have a temp sensor header that you can use with any 10K probe so that you can monitor the coolant temp and, more importantly, index your fans to the coolant temp, and I'll show that later on during the thermal performance. That also means you don't need a fan controller for your build, which will save you a little bit of space. Finally, I did add a drain valve on the bottom rad, since this is a cross-flow version, which tucks in neatly into the space under the front panel. In terms of fan configuration, a reasonable approach is to have the radiators intaking so as to get cooler outside air, and since with the tempered glass panel, it becomes a fairly positive pressure system, the case will see the air exhaust out the back primarily. Speaking of fans, in terms of thermals, even with the glass panel, we are looking at very good thermal performance. Normalized to an ambient temp of 25 degrees C for Red Dead 2 at 1440. With the 2070 overclocked to 2040 megahertz and at full utilization, the GPU hit equilibrium at 56 degrees, and the CPU reaches about 60 degrees. It fluctuates around there on an all-core OC at 4.2 gigahertz. The coolant sat around 39 degrees with the fans at 1200 RPM and reaching about 1.3 to 1.4 decibels over the noise floor at 20 centimeters away. So essentially, you really can't hear the system when it's a reasonable distance away. For a little less resource-intensive game like Anno 1800, the GPU hits about 55, 56 degrees. The CPU similarly hovers between 55 and 60 degrees, but the fans are lower for a less resource-intensive game, and they can stay around 1100 RPM. Because I didn't want the coolant to cool off, I ran the 3900X with an all-core OC at 4.2 gigahertz and 1.25 volts for Blender, and the CPU hit 68 degrees with the coolant sitting at 39 degrees and the fans only at 1000 RPM. With fans at this rate, the system hits a noise level of 1 decibel above the noise floor. Of course, the bottleneck here with the CPU is more the thermal transfer from the chiplets to the IHS, but this is still a very decent custom loop temperature for the 3900X. This particular chip, though, can be pushed harder, and I was able to get it up to 4.4 gigahertz on all cores at 1.4 volts, and that saw some fairly decent results in Cinebench R23. If you're wondering about motherboard temps with this setup, the chipset stayed in the high 60s. With this particular airflow setup, there's enough going across the motherboard. In fact, with a positive pressure system exhausting out the rear, it's ideal for helping the motherboard stay cool. The real winner here is, of course, the noise levels for the system, which, since the system features 4 fans, which do double duty as case and rad fans, is very quiet. In terms of noise optimization, typically with a DDC pump, I'll run up to 30% at 30 degrees of coolant temperature, 40% at 40 degrees, and 50% up to 50 degrees of coolant temp. And then I'll ramp up to 100% at that point at 60 degrees, since something is really wrong if your coolant's hitting 60. Xylem DDC pumps are generally noticeable above 50%, and they get progressively louder after that. But these are very effective pumps at low RPMs, as opposed to a D5, which is quieter at equal percentages, but has to run at higher percentages to be effective. For setting up the fan RPMs, this is really to taste. I went ahead and set it up in BIOS, but you can also use ASUS's AI Suite 3 for this. It's easier to screen record there, so I just did that in there. I just have these set up at 30% at up to 27 degrees of coolant temp, and then I'll ramp up to 60% at 45 degrees, and then I'll do a hard ramp up to 100% at 50 degrees. At least with the ASUS fan headers, you'll want to hook up to the case fan header if you want to index to coolant temp, since I haven't found a good way to remove CPU temperature dependence from the CPU fan header on ASUS boards. For the testing so far though, the coolant will hit 39 degrees depending on the ambient temperature, and that's perfectly fine overall, especially in an SFF custom loop. So all in all, I think this is the best way to run two rads in the NR200, since at least for me, a huge part of the fun is the looks, and I think for how much effort one would put into this, you really want to be able to see it. This way you have more flexibility with pumps. A normal cylindrical pump res could also fit here, but I rather like how the squarish look of the XT3 lines up with the PSU shroud, and that FLT 120 would also look great in here. So this won't be the final iteration of the build. Along with putting in the 3070 block, I'm also going to be throwing in Ryzen 5000 in here. Probably the 5600X actually, since this will primarily be a gaming build. Anyhow, hope you found this entertaining and informative. If you have any questions about this demo build, please feel free to comment. I've also left the full parts list linked down below. And hey, if you haven't subscribed yet, and you think you might enjoy the content here on the channel, I would appreciate it if you would hit that subscribe button. So thanks for watching today, and I'll see you again soon.